Hello, everyone. In today's video, we are going to dive into 8 fascinating stages about the sun, from its structure to its cultural impact. Ready to enlighten your minds? Let's go. Number 1. Structure of the sun. The sun, a giant and luminous star at the center of our solar system, is an inexhaustible source of fascination and curiosity. Although it may appear as a uniform sphere of light from Earth, the sun has a complex and well-defined internal structure, composed of several layers, each playing a crucial role in its functionality and the phenomena we observe. In the core of the sun, we find the heart of the star, where nuclear fusion reactions occur. It is here that 4 hydrogen nuclei combine to form a helium nucleus, a process that releases energy in the form of radiation. This energy is so intense that the temperature at the core can reach about 15 million degrees Celsius. The core is surrounded by the radiation zone, an area where the energy generated in the core is transported outward through the absorption and re-emission of photons, a process that can take thousands of years for the energy to move just a small distance. Above the radiation zone, we find the convection zone. In this layer, energy is transported more efficiently through the movement of masses of hot gas rising and cold gas descending. This movement creates convection patterns that are fundamental for transporting energy to the surface of the sun. The visible surface of the sun is known as the photosphere. It is in this layer that the sunlight that illuminates and heats our planet is emitted. The photosphere has a temperature of about 5,500 degrees Celsius and is also where we can observe phenomena such as sunspots, which are cooler regions caused by disturbances in the magnetic field of the sun. Above the photosphere, the sun's atmosphere extends into 2 main layers, the chromosphere and the corona. The chromosphere, which is seen as a ring of red light during a total solar eclipse, serves as a kind of intermediary between the photosphere and the corona. The corona, the outer part of the solar atmosphere, is extremely hot, with temperatures that can exceed 1 million degrees Celsius. It is in the corona where coronal mass ejections and other solar phenomena that can directly affect Earth occur. Understanding the structure of the sun not only allows us to appreciate its complexity, but also helps us better understand how it influences our solar system. Each layer of the sun works together to sustain life as we know it, regulating natural cycles and providing the energy necessary for life on Earth. Number 2. Solar energy. The sun is the primary source of energy for our planet, but how exactly does this giant star generate so much energy? The secret lies in the nuclear fusion reactions that occur incessantly in its core, an extremely hot and dense region. This stage of our video will dive deep into the depths of this powerful solar furnace to understand the process that lights up and warms the Earth. In the heart of the sun, the core, the temperature reaches about 15 million degrees Celsius. These extreme conditions create the perfect environment for nuclear fusion, a process where nuclei of light atoms, predominantly hydrogen, collide with such force that they fuse, forming a heavier nucleus, like helium. This transformation releases a huge amount of energy in the form of radiation. For every 4 hydrogen nuclei that fuse, 1 helium nucleus is produced, also releasing particles such as positrons and neutrinos, along with a vast amount of energy in the form of photons. These photons, or particles of light, do not immediately escape into space. They begin a complex journey through the various layers of the sun, a process that can take more than 100,000 years. Initially, the photons move through the radiation zone, where they are absorbed and re-emitted repeatedly by particles of matter, moving only small distances with each interaction. This stage is crucial, as it allows the energy to be slowly transported to the surface of the sun without the star exploding or collapsing. Upon reaching the convection zone, the photons find a new form of transport. Here, energy is carried upward by convection currents, masses of hot solar gas rising while the cooler gas descends. This movement helps to transport the energy more efficiently to the photosphere, the visible surface of the sun, where the energy is finally released into space as light and solar heat. The amount of energy released by the sun is colossal. Every second, the sun converts about 600 million tons of hydrogen into helium, releasing energy equivalent to billions of megatons of TNT. This energy travels through space and, after about 8 minutes, reaches the Earth, providing the light and heat that sustain almost all forms of life on our planet. This energy generation process not only sustains life on Earth, but also plays a crucial role in the dynamics of our solar system. Understanding nuclear fusion in the Sun helps us explore potential sources of clean and nearly inexhaustible energy here on Earth, inspiring scientists to develop nuclear fusion technologies that could one day provide abundant energy without the risks associated with traditional forms of energy generation. Number 3. Solar cycle. The Sun, our central star, is a dynamo of varied activities that not only lights up our day, but also exerts a profound influence on our space environment. One of the most fascinating manifestations of this activity is the solar cycle, which has an approximate periodicity of 11 years. In this stage of the video, we will explore what the solar cycle is, how it is measured, and what its effects are on both the Sun and Earth. The solar cycle is marked by variations in the number and size of sunspots, which are cooler and darker regions on the surface of the Sun caused by disturbances in the solar magnetic field. The cycle begins with a solar minimum, where few or no sunspots are visible. Gradually, solar activity increases until it reaches the solar maximum, a period during which the number of sunspots and solar activity, such as flares and coronal mass ejections, are more frequent and intense. After the peak, solar activity decreases again, returning to the solar minimum and starting a new cycle. But how exactly does this happen? The solar cycle is driven by a dynamic solar magnetic field. In the core of the Sun, the movement of hot plasma and the differential rotation of the star, where the solar equator rotates faster than the poles, generate and intertwine magnetic fields in a process known as the solar dynamo. Throughout a cycle, these magnetic fields twist and reorganize, emerging on the solar surface as sunspots and other activities. These fluctuations are not just a visual spectacle with the aid of solar telescopes. They have direct implications for Earth. During the solar maximum, the amount of ultraviolet radiation and X-rays increases, which can affect the upper layers of our atmosphere, causing atmospheric expansion and increasing drag on low-orbiting satellites. Furthermore, solar storms, which are more common during these periods, can disrupt radio communications, damage satellites, affect electrical grids, and even create beautiful auroras at the Earth's poles. Therefore, monitoring the solar cycle is vital for predicting space weather and mitigating the adverse effects of intense solar activity. Space agencies such as NASA and NOAA operate observatories that constantly monitor the Sun, providing essential data for research and for the protection of our technology and infrastructure. By understanding the solar cycles, we not only gain insights into the dynamic nature of our own star, but also improve our ability to live and operate safely both on Earth and in space. Number 4. Impact on Earth. The Sun is not just a distant source of light. It has a profound and direct impact on our planet in various ways. In this stage of the video, we will explore how solar energy and solar storms affect the Earth, influencing everything from the climate to the technologies we use daily. The most fundamental influence of the Sun on Earth is through its radiation. The heat and light from the Sun are essential for maintaining our planet's temperature at a level that supports life. Solar energy drives climate cycles, heating the oceans and the atmosphere, which in turn influences wind patterns, rainfall cycles, and global climates. Variations in the amount of solar radiation received, even if small, can affect Earth's climate. Studies suggest that historical periods of solar minima, such as the Maunder minimum during the Little Ice Age, may have contributed to colder climates in some regions of the world. Besides climate, more intense solar activity, especially during the peaks of the solar cycle, can lead to phenomena known as solar storms. These are coronal mass ejections and solar flares that launch energized particles and radiation into space. When these particles hit Earth's magnetosphere, they can cause the spectacular northern and southern auroras, but they also have the potential to disrupt technology. Solar storms can induce electric currents in the ground and oceans, affecting energy distribution systems and even leading to large-scale power outages. For example, in 1989, a solar storm caused a massive blackout in the province of Quebec, Canada, leaving millions without power for several hours. Moreover, increased radiation can damage satellites and other space equipment, affect satellite navigation and communication systems, and increase risks for astronauts on space missions. Understanding these impacts is crucial for developing mitigation strategies. For instance, Power grid operators can reinforce their infrastructures and develop emergency protocols to minimize the effects of geomagnetically induced currents. Similarly, space agencies constantly monitor solar activity to protect equipment and crews in space, especially during periods of intense solar activity. Therefore, while the sun energizes and sustains life on Earth, its influence can also challenge modern technology and the infrastructure we have built. Understanding these effects not only allows us to appreciate the complexity of the interactions between the sun and Earth, but also drives us to develop technologies and strategies to live more safely and efficiently in our dynamic planetary environment. Number 5. Solar exploration. Exploring the sun is a fascinating journey that helps us better understand our closest star and the influence it exerts over the solar system. In this stage of the video, we will explore the space missions that have been launched to study the sun, highlighting their discoveries and pioneering technologies. One of the first missions dedicated to studying the sun was the Solar and Heliospheric Observatory, SOHO, a collaboration between the European Space Agency, ESA, and NASA. Launched in 1995, SOHO has been instrumental in observing the sun, allowing scientists to view structures on its surface and atmosphere with unprecedented detail. One of its most significant findings was the detailed visualization of plasma currents beneath the surface of the sun, which helps to explain the phenomena of solar convection that affect space weather. Another revolutionary mission is NASA's Parker Solar Probe, launched in 2018. This probe was designed to get closer to the sun than any spacecraft before, diving into the solar corona to collect data directly within the sun's atmosphere. The Parker Solar Probe is helping scientists better understand the corona, which is mysteriously much hotter than the solar surface, and the origin of the solar wind, a stream of charged particles that can influence space weather throughout the solar system. The Solar Orbiter, launched in 2020 by the ESA in collaboration with NASA, is also bringing new perspectives on the sun, equipped with instruments that can capture images of the sun in multiple wavelengths. The Solar Orbiter is investigating how the sun creates and controls the heliospheric environment. One of its goals is to map the solar poles, areas that are little studied but crucial for understanding the solar magnetic field and its impact on the surrounding space. These missions are complemented by a network of ground-based telescopes and other satellites that continuously monitor the sun, providing a nearly continuous view of its activity. Each new discovery provides valuable information for models of space weather prediction, essential for protecting terrestrial and space technology from solar storms. Solar exploration not only expands our knowledge about the sun, but also improves our ability to predict and mitigate the effects of its activity on our technological environment and on Earth. As we continue to advance in this field, each mission brings us closer to unraveling the mysteries of the sun and strengthening our resilience against the challenges of space weather. Number 6. Curiosities about the sun. The sun, although familiar, hides within it a series of surprising facts that awaken both curiosity and awe. In this stage of the video, we will explore some fascinating curiosities about this star that dominates our solar system. Firstly, the sun contains more than 99.8% of all the mass of the solar system. This means that all the planets, asteroids, comets, and interplanetary dust together make up less than 0.2% of the total mass of the system. The immense gravity of the sun is what keeps all these bodies in orbit around it. Another impressive fact is the size of the sun. If it were hollow, about 1.3 million Earths could fit inside it. This vastness is hard to imagine, but it gives a sense of the gigantic scale of our star. Despite its size and mass, the sun is not an exceptionally large or massive star compared to other stars in the universe. In fact, it is classified as a medium-sized star. The sunlight that reaches Earth currently took about 8 minutes and 20 seconds to travel from the sun to us. This means that whenever we look at the sun, we are seeing it as it was almost 8.5 minutes ago. Moreover, this light began its journey thousands of years ago, traveling from the core of the sun to the surface before escaping into space. The sun is also a source of solar wind, a flow of charged particles that spread throughout the solar system. These particles can create beautiful auroras when they interact with Earth's atmosphere, but they are also responsible for disrupting communication and navigation satellite systems. Finally, although the sun is at least 4.5 billion years old, it is only in the middle of its life. It is expected to continue shining for about another 5 billion years, after which it will evolve into a red giant and, eventually, become a white dwarf, marking the end of its stellar journey. Each of these facts not only broadens our understanding of the Sun, but also helps us put into perspective the complexity and beauty of the universe in which we live. Number 7. Importance for life on Earth. The Sun plays a central role not only in the solar system but also in the very essence of life on Earth. In this stage of the video, we will explore how this star fundamentally and subtly influences life, sustaining and shaping the existence of all living beings on the planet. Sunlight is the basis of photosynthesis, the process by which plants convert light into chemical energy. Without the sun, photosynthesis would not occur, which would mean that plants could not produce oxygen or serve as the basis for the food chain. Practically all the energy that sustains terrestrial ecosystems comes, in one way or another, from this solar conversion into energy usable by life. In addition to sustaining the food chain, the sun regulates biological cycles. Many living beings, including humans, have circadian rhythms that are synchronized with the cycle of light and darkness provided by the Earth's rotation in relation to the sun. These rhythms influence critical functions such as sleep, eating, reproduction, and social behavior. Solar radiation is also vital for human health in several ways. Moderate exposure to the sun allows the human body to produce vitamin D, essential for bone health and for the regulation of the immune system. A lack of sunlight can lead to vitamin D deficiencies, negatively affecting bone health and increasing the risk of various chronic diseases. On the other hand, the sun also presents challenges to life. Excessive exposure to ultraviolet radiation can cause skin damage, including sunburn and skin cancer. Thus, humans have developed various strategies to protect themselves from the harmful aspects of the sun while enjoying its benefits. Furthermore, Earth's climate is strongly influenced by solar energy. Variations in the amount of solar energy received can cause significant climate changes. For example, small variations in Earth's orbit and the tilt of its axis can lead to periods of global warming or cooling over thousands of years. In summary, the sun is essential for the existence and maintenance of life as we know it. It not only provides the energy necessary for life on Earth, but also shapes the natural environments in which we live, demonstrating the power and importance of this star in the cosmic context and in daily life. Number 8. Mythology and culture. The sun has been a source of inspiration and veneration in cultures around the world since time immemorial. In this final stage of the video, we will explore how different civilizations understood and revered the sun, highlighting the cultural and spiritual impact of the star across various traditions throughout history. In Egyptian mythology, the sun was personified by the god Ra, considered the king of the gods and the creator of the universe. Ra was often depicted as a man with the head of a falcon, crowned with a solar disk. Each day, he crossed the sky in his solar bark, symbolizing the journey of the day, and traveled through the underworld at night, reflecting the daily cycle of sunrise and sunset. The Aztecs, in turn, saw the sun as a warrior who fought daily against the forces of darkness. They believed that to ensure the continuity of the solar cycle, it was necessary to offer human sacrifices to feed the sun with vital blood. This belief was deeply rooted in their cosmology and had a significant impact on their cultural practices and rituals. In Norse mythology, the sun was represented by Sol, or Suna, a goddess who guided the chariot of the sun across the sky, pursued daily by the wolf skull who sought to devour her. This mythology reflects the constant struggle between light and darkness, a common theme in many cultures. In Japan, the sun is represented by the goddess Amaterasu, who plays a crucial role in Shintoism. According to the myth, Amaterasu hid in a cave, leaving the world in darkness, until the other gods convinced her to come out, bringing the light back to the world. This myth symbolizes the importance of the sun in regeneration and the continuity of life. Beyond mythology, the sun also plays a central role in many festivals and traditions around the world. For example, in India, the Makar Sankranti festival is celebrated to honor the movement of the sun to the north, an auspicious event that marks the arrival of spring. These stories and traditions not only demonstrate how the sun has been and continues to be an essential part of human cultures, but also how it influences our lives in ways that go beyond the physical. The sun is not just a star in the sky. It is a powerful symbol of renewal, energy, and life, deeply woven into the fabric of many spiritual and cultural traditions around the world. I hope you have enjoyed exploring the wonders and mysteries of our sun. Don't forget to subscribe to the channel, leave your like, and comment below which was the most surprising information you discovered today. Hit the bell to not miss our upcoming videos. See you next time.